Hello everybody, my name is Mike Bartles and I was the HEC HMS team lead through the release of version 4.9, which was posted to our website in January 2022. This video is a recording of our 5th quarterly HEC HMS webinar, which took place on March 3rd, 2022. Within this video, several members of our team demonstrate features within version 4.9 that they personally developed. The video starts with a little bit of an HEC HMS history lesson before introducing all of the presenters. Afterwards, each one will demonstrate their new features. At the end, questions posed during the presentation are answered by the HEC HMS team. Enjoy!
So if you were to take a step back in time and look at the HMS team about 4 years ago, you would have found that 2 to 3 people worked full-time on code development, while 2 or 3 folks like myself helped with testing that new code. Since that time, our team has nearly tripled in size. So for instance, during development of version 4.9, we had approximately 15 people, and nearly all of them working full-time committed code to HMS. So within the webinar today, you're going to meet some of the newest members of our team and see them present many exciting new features that they personally developed. At the end of the presentation, we have dedicated time set aside for discussion and questions. First up is going to be Nick Van, who is a computer scientist and refactoring wizard who specializes in nearly all aspects of code development and multi-platform compilation and deployment. So if you use HMS on a Mac or Linux operating system, you have Nick to thank for that. After Nick, you'll hear from Daniel Black, who actually holds both a bachelor's and master's degree in geology. But as you'll no doubt pick up from his segment today, he's truly a jack of all trades and is equally adept with both hydrologic modeling and rock samples. Following Daniel, Natasha Sokolovskaya will present some really nice quality of life enhancements within HMS, which I've wanted to see for a really long time. Really pumped about them. And finally, David Ho will go after Natasha. David is a hydraulic engineer who works on Monte Carlo applications, features, and testing within HMS, and is helping our team take real-time performance tracking to the next level. All right, I'd first like to give a shout out to our partners who actually funded us to add the enhancements you're going to see today. The list of partners includes the USACE General Investigations Program, the Mississippi River Geomorphology and Potamology Program, SWIM's National Implementation Program, the USACE Science and Engineering Technology Program, and the Northwest Division Columbia River Basin. This webinar is being recorded and the video is going to be posted to our website soon. Everyone is on mute to minimize disruptions, so please type your questions in the chat. We'll either answer them there or get to them at the end, or we're going to email you back. So without further ado, I'll get started and give the mic over to Nick. Go ahead, Nick.
Hi, everyone. First, I will present about the gridded data importer. The purpose of this utility is to streamline the process of converting various gridded dataset formats into HEC DSS format to be able to use within HEC HMS. Currently, the gridded data importer support conversions from dataset formats such as NetCDF, HDF, GRID, ASCII, TIFF, BILS, NODAS, and DSS files. In addition to the ability to convert dataset to DSS format, the gridded data importer utility is also able to project gridded data to SHG or UTM projections, clip to watershed boundary, and set correct data units and type. I'll send a link in the chat shortly to a tutorial and guide on how to use the gridded data importer utility to work with gridded data. When you navigate it to the tutorial and guide link posted in the chat just now, you will be able to see a link to gridded data sources page. This page contains a table that shows some of the gridded hydrologic data sources that can be used to inform hydrologic modeling. This table also includes the data sources, domain, period of record, time steps, resolution, format, and a link to the source archive. Next, I'll talk about the normalizer utility. The purpose of the normalizer utility is to develop a precipitation dataset that captures one grid data source temporal variability while also capturing the total precipitation volume of another gridded data source. A typical usage of the normalizer utility is when you have two sources of data, one of which captures the temporal variation well due to its smaller time steps, but under or overestimates the volume. An example of such a data set is the hourly stage 4 radar data set. Meanwhile, you also have another data set that captures the total precipitation volume well, but doesn't capture the temporal variation well due to its larger time steps. An example of such a data set is the daily prism data set. As such, the goal of the normalizer utility is to take the advantage of each of those data sets and create a better and normalized data set. For instance, the normalizer would normalize the stage 4 data set using the daily prism data. The normalizer will be using the formula here below to adjust the magnitude of each grid cell in the stage 4 radar data, which captures the temporal variations well, so that the stage 4 data total volume would match with the daily prism data total precipitation volume over a user-defined time interval. Let us take a look at the effects of the normalized data set visually. Here, you can see 4 graphs. The top 2 graphs represent a visualization of the 3 data set, with pink representing the daily prism data set, the light blue representing the stage 4 data set, and the black line representing the normalized data set. As you can see, the normalized data set is able to capture both the temporal variation from stage 4 data set and also the more accurate total precipitation volume from the daily prism data set. The 2 graphs below are the computed and observed hydrographs from 2 simulations. The color blue in these graphs represent the computed flow, while the color black represents the observed flow. The lower right graph shows how the normalized data set is able to be used to compute a better matching computed flow graph. So you can see that here the computed flow and the observed flow graph match pretty closely. I'll shortly send a link in the chat to a tutorial and guide for the normalizer. Now I'll pass on the mic to Daniel to present the next utility. Thank you.
Okay, so now I'm going to talk about a few more of the Vortex utilities that we've added. I'll go through a brief slide for each one, and then I'll do a demo. The first utility is the grid-to-point converter. This utility is used to convert gridded data to a basin average time series data. That results in both XY plottable data and tabulatable data. Some benefits are having faster computes, as well as being able to do some gridded data conversion to provide time series for observed data for our time series gauges. The next tool that I'll demonstrate is the Sanitizer. This tool is used to screen and replace values above or below a selected threshold. You can see on the slide, we have some gridded precip data. That gridded data includes some negative values, which results in sort of a bloated file size. So by using the grid sanitizer, we can replace those negative values with a 0 and get rid of the negative values. HMS can handle negative precip, but it's better to just have zeros. It will result in a much faster compute. If you follow the arrows to the end there, you can see the precip 2000 June.dss file. That is the initial data set. The sanitize.dss file is the sanitized file, and you can see that we have a file size reduction of about 99% just by removing those miscellaneous negative values. The third tool that I'll go over is the calculator. This tool is used to perform simple arithmetic on data, so you can multiply, divide, add, and subtract on your grids. Some use cases are providing alternative data sets, so you can scale precip or temperature data. For example, you can quickly increase your precipitation by tenfold or reduce temperatures by a degree. You can also do things like unit conversion. So if you have temperature data, for example, in some wonky units like Kelvin, you can quickly replace those with Fahrenheit units. So now I'm going to go over the demo of the utilities, but first we have some bugs that we need to address that were in the HMS 4.9 release. So there's a couple of jar files that need to be replaced. You can get to this page from the HEC website. I'll post the link when I'm done presenting. But if you go to the HMS section, and then either the downloads or documentation page, you'll see the release notes. And you can scroll to the bottom of the page, or you can use the right pane, scroll to the bottom, find grid to point converter and calculator utility, and that will take you here. You would download these two files, which I have already done. I've placed them in a folder on my desktop. And on the left side, I have the HMS 4.9 portable version open. You can only do this with the portable version. So the first thing you would do is open the lib folder, scroll to the bottom, and you will see the Vortex and Vortex UI 0.10.26 jars, which are the jars we need to replace. And we'll just highlight those and delete, and then you can simply drag and drop. And now we've updated our jar files, so we have a bug-free version of our Vortex utilities. So now I'm going to open up HEC HMS 4.9, and the first tool I'll demonstrate is the grid to point converter. So we select Tools, Data, Grid to Point. The first thing that we have to do is select the source file. So I'm going to select some precipitation data. I'm going to select all of the grids. These are all of the grids that are within the DSS file that I've selected here. I'm going to move them to the right, hit next, and now we have to pick a zone shapefile because we're using the zone shapefile to get the area for the basin average. So I'm going to select the shapefile that we're using for this subbasin. Then we have a field selection. If you're familiar with GIS, then you know that shape fields have attribute tables, and attribute tables have fields for things like the latitude, longitude, area, things like that. I'm going to pick the name field, and what this is going to do is assign the name field to the B part of our new grids, or our new DSS file. Finally, I'm going to pick a destination. So I'm going to pick grid to point.dss. If you don't have a DSS file ready, you can type in a path name here and it will create it on the fly. I'm going to leave everything else to defaults and hit next. And that's it. So now I'm going to open up DSS. This is the original DSS file with our 457 grids for precip. And this is our new file, which has been converted into point data. We have two entries, cumulative precip and incremental precip. I'll just plot the incremental precip. And you can see we have a new data set here with each point representing the base and average for a particular grid within the previous file. So now I'm going to demonstrate the sanitizer. And for the sanitizer, we're going to first pick a source file, which is going to be this guy. It's the same one from the slide. I'm going to select all of the grids. And we're only going to filter values below a threshold in this example. So we had negative values in our precip. So I'm going to replace anything below or equal to 0 with a 0. And then I'm going to pick a destination and leave everything else default and hit next. And we're done with this. So this is our initial grid, and I'll just tabulate it separately. And this is our sanitized refresh, and I'll just plot the first one or tabulate the first one. And you can see we have negative values here in the original, and now we have replaced those with zeros. The final tool is the calculator. So again, selecting a source file. Gonna go ahead and select all of these and move them over. Hit next, and now we have to pick some arithmetic function. For simplicity, I'll just add a 1 to everything. Hit next. Pick a destination, hit next, and it's done. So this is our original data set. I'm just going to tabulate grid 38. 38. And you can see in the original data set, we had a max value of 2.31 and a min value of 1.0. And now we have in our new data set, a max value of 3.31 and a min value of 2.0. So we just added 1 to each grid. That's the end of my demo, and I think now I'll turn it over to Natasha.
Thank you, Daniel. Hi, everyone. So as Mike mentioned, the next 2 features I'll talk about are intended, and I think successfully, to make a modeler's life a little easier. One of them is the file references dialog that I think we have a few team members to thank for, Tom and Josh among them. And this is a great improvement because now it displays most of the data sources referenced in the project in a single table. And this is what this table looks like. You can see that some paths are highlighted orange. This is when a file referenced is external, which means it's outside of the project folder. And then if a link is broken or if the reference is invalid, the path would highlight red, which is good to know. Also, for a larger project with multiple references, it's helpful to filter these either to only show invalid references or filter them by data type. To get to this dialog, go to the File menu and select References. This will bring up the dialog just like this, or also if we have broken links, the dialog will come up when you try to run the project and will show broken links or invalid references. Currently, if we want to fix these links, we can type in a correct path name individually in each row, or we can browse to the correct location. We hope to improve it even further in the future and allow to copy the table or portions of the table so that the links can be updated in Excel several at a time or whatever you need to do with the path names. So why do we think this is really cool? Often when we were asked to troubleshoot a model, sometimes a file was not included or it would get lost in the process of copying, zipping, emailing, and all that. And we'd get an error or the project just wouldn't run and it wasn't obvious what the problem was. Now, it's much easier to track these and fix them if they're all in one place. So this is a good place to remind everybody that it's helpful to save data sources internally in your project's data folder to avoid these issues with losing things and breaking links. Now another new feature, and this is like my first dab into Java or HMS. This one is also making modeler's life a little easier by letting us rename multiple basin elements in a single place instead of right-clicking on them in the basin tree the way we did before. So if if a watershed was named after you and you want to update your model, you have a choice to do it individually for each element, a sub-basin, reach, or whatever, or you can copy the whole table to Excel and then just modify everything there and bring it back in. Also again, if you have a really large, complex project, it's very helpful to filter elements. So you can just filter by type, only see sinks or only see subbasins, or you can sort them hydrologically or alphabetically. To get there, you can right-click on the basin's name and select Rename Basin Elements. And this is just an illustration of a really large, complex basin with many different basin element types where such table could be really helpful. So now we'll switch gears a little bit and David will talk about runtime tracking in HMS. Thank you.
Yeah, so in addition to adding and improving features in the HMS program, we've also set up a system for tracking runtimes in HMS. And when I say runtimes, I'm referring to the amount of time it takes for a simulation to run from start to finish. So as developers, we can see whether new builds of HMS are changing runtimes higher or lower. And as HMS users, you will hopefully see new versions compute faster over time. So having runtime framework be part of our development process, we believe will benefit HMS users, especially if you have really data-intensive projects. So for example, most water management groups have SWIMS models where you might be asked to produce an inflow forecast to a reservoir model within the next 6 to 24 hours. And so that involves having to get your HMS model calibrated quickly. And ideally, you don't want to have to wait a long time between parameter adjustments. For those of you who use HEC Watt, any means of reducing runtimes can mean hours or days saved when you run a FRA Monte Carlo analysis. And that computational time that you save, it can translate not only to just a reduced time, but also savings on project costs. I've also seen users start running continuous simulation models on sub-daily time steps, running the simulation from months out to a couple of decades, which can also involve long computation times. So having reduced runtimes can help with these types of projects. As HMS developers, we want to know if a feature that we're adding isn't inadvertently causing the software to run slower. The way we've set up our tracking system is to provide fast and continuous feedback to our developers, which is one of the DevOps principles to efficient software development. So the next few slides is not going to describe any new feature in HMS, but it'll give you a behind-the-scene look into how we are implementing runtime tracking in our development process. So across the HMS versions, we have seen a reduction in the compute time. Here is a graph showing the runtimes for 5 different projects that are tracked from versions 4.3 to 4.8. And there was a big reduction in the HMS runtime from 4.3 to 4.5. And depending on the type of project, on average is about a 55% reduction. And hopefully you've probably noticed this increase in speed if you've been using HMS for a while. And it's also an incentive to upgrade your version if you're still using 4.3. The runtime reduction came from the ability to perform parallel computes for subbasins and reach networks, which has the most benefit for dendritic pattern watersheds where you have a lot of first order streams. And the other major improvement was how paired data tables were being read. And paired data tables are normally used for defining reservoir channel geometry. And so reading those paired data relationships is now much more efficient. There's also runtime improvements that are not reflected in this chart. In version 4.4, the HMS team added the compute to point feature, meaning you can just compute to a specific element and not have to rerun the whole simulation. And there's also improvements to the GIS delineation and processing where you can adjust the number of cores being used, and so help your runtimes there. And so there have been successful efforts to improve runtimes. However, you might have noticed that there is a slight increase in runtimes from 4.5 to 4.8. As a tracking framework, this graph that I'm showing was produced manually. And so like for each project, I had to run the simulation for each version, then noted down the runtimes for the project. And so this is really inefficient and error prone. Takes a lot of time to do, and it doesn't provide that fast continuous feedback to our developers, as they're adding new features to HMS. So we need a better way to review and track our runtimes. And so this is where our framework comes into play. We've created a system for tracking runtimes as part of our automated build process. We use a program called TeamCity that does that automated build for us, or we can set up and obtain useful runtime metrics. So within our build process, we can track runtimes for various types of HMS projects. And then this information can be provided to our developers as new features are getting added. So if a new feature that is added increases the runtime for a particular project, the developer can then see that in the development process and then go back and investigate why that might be the case. So that's what those graphs are showing on the left and on the right. The XY plot on the left shows the build number on the x-axis and runtimes on the y-axis for each HMS project. The different lines on the graph represent different versions of HMS. So for example, the Willamette project, which we're tracking, we're comparing the runtimes for versions 4.8, 4.9, and the current development version. And the table on the right compares the current release HMS to the development version of HMS and provides a more detailed look at the differences in runtimes between the current release and the developed version. And if you look closely on the left graph, you might notice that for the Willamette project, our runtimes between 4.8 and 4.9 did increase. That is kind of a bummer, but we are aware of this and we have data points that can show us that this is the case. And so we are looking for ways to diagnose why that might be happening. And so this is the way that we diagnose by using a profiling tool. This is getting more into the weeds of our development process, but profiling is just a way of figuring out where our bottlenecks might be. And if we can find where those bottlenecks are, we can hopefully go to that point in the code and improve it. So lastly, this just shows the types of projects we are currently tracking. We're trying to cover a range of projects and compute types. So for example, in the simulation type, we are tracking our typical simulation runs, forecast alternatives, optimization runs. For discretization, we are tracking structured and unstructured, where unstructured grids do involve the 2D features in HMS. We're also tracking different types of mirror logic methods, like the gridded precipitation and basin methods. And we'll be adding to this table as more features are added to HMS. If anyone doesn't see a project type listed that they would like us to keep track, you can let us know and we'll add it to this table. So at this point, I think I'll pass it over to Mike, who will field questions.
Yeah, excellent. I'm super, super proud to see all of the stuff that's being added to HMS. I love it all. Love it all. All right, we had some good questions coming into the chat. We'll kick it over to Matt to see if we got any good ones for discussion.
Yeah, there's a few that we could dive into here for a few minutes. One of them that I see, how does the converter handle different projections of precipitation data and subbasins? This is a really good question. This is something that's come up a few times in the last couple of weeks, and even I learned something new just the other day. You can have a basin model projection. For example, I think most of us in the Corps were using the Albers equal area feet projection, the standard MMC projection for a basin model. And then the gridded data, precipitation, temperature, that data is going to be stored in DSS for most of the HMS applications. And in the past, there were only two supported projections, the standard hydrologic grid, which is the Albers equal area meters, and then UTM. And in the past, we really emphasized that both the MET data, the meteorologic data, and the basin model should be in the same projections. But now that's not the case. With these wonderful new tools, you can have your precipitation data in standard hydrologic grid meters, and then you can have your basin model in a state plane projection or a UTM projection or whatever projection you're comfortable working with. When you run the simulation, the program is going to take care of reprojecting the basin model elements into the same projection as the data and do the computations. So it's much more flexible than it used to be. And then the one thing that I learned this last week is that even in DSS, the limitations of just standard hydrologic grid and UTM have been opened up. So even storing gridded data in DSS, you can utilize different projections there. So that was a good one. And then the other question I see there, how do you update version 4.9 if you don't have the portable version? So let's just say you have the Windows version. So what you can do is you can always have different versions or different copies of the same version on your computer. So if you have the Windows version of 4.9, then you could download the portable version and update the jar files just like Daniel showed. Or you could migrate to version 4.10. We already have beta 1 up there and start using that version 2 with the updated jar files there. So that's answer to those two questions. Tom or Greg, did you see any other questions that you want to dive a little deeper into?
Yeah, on the Vortex stuff, yeah, you can update the jars like you're talking about, and then you can always download the standalone packages. I put a link to where those are hosted on GitHub, so if you're interested in that, those have been available for a long time. So that's how to get the latest and greatest, and the next time an HMS beta goes out, it'll always include the latest libraries. But just to note, those bugs that we found were just in the initial implementations of grid to point converter and calculator. So if you're using the other utilities, you should be fine in version 4 now.
Yeah, we had a question in there about mixing and matching sources of meteorological data. For example, using gridded precipitation with time series temperature, for example. And that's actually something I do quite a bit. In a lot of my watersheds, if I need only really a ballpark estimate of temperature for the basin just to do ET and get the water balance about right, then I'm not going to spend a lot of time and effort on pulling a bunch of temperature grids in to do that kind of modeling. But the rainfall spatial patterns and temporal patterns are much more important for getting my response right. So I'll pull gridded data in to do that. And that's reducing my project size, the computation time, and all of those things. Now, in the situation where perhaps you're doing snow modeling and you need a better estimate of the change in temperature over your watershed, then in that situation, it may make sense to try to pull in gridded temperature to do that. But The beauty of the way that the meteorological model is generalized in HMS means that you can mix and match data sources that are appropriate to the modeling tasks that you have. So, today we're trending towards using precipitation, gridded products as much as we can in that because they offer a better answer. But for some of the other meteorological inputs, it may not require that level of fidelity right now, but for some modeling applications it does. So it's flexible enough to handle all of those cases.
I want to say thanks to Mirza, too, for throwing in a link to some additional data sources there. We would love to include stuff that people have tested, shown that's worthwhile, and they want the other community members to know about. That was the whole idea of that big table that Nick showed right from the get-go. I love those sources of data. It's helping out the community. So if you guys got other ones, please send them our way. Let us know. Please make sure that they're freely available to others, though. So don't throw up data sources that cost $10,000 to download or something like that, because we can't necessarily get at those. But let us know what works for you. Also saw a good question from Adrian asking about the default DSS version that's created if you don't specify a previously existing file. Tommy answered that one. Very, very good point, though. HMS can read both version 6 and version 7 files. By default, we write out version 6 from HMS. Vortex will write out version 7 files, but you can play with either one. It's all good. You can use either format there. Don't be afraid of those ones. Got some good questions about Prism. Greg, I think those ones are best suited to you, dude. Asking how applicable Prism is.
Yeah, Prism is excellent for volumes in general because it's overlaid multiple sources of data and at a daily time step. It's generally going to do a good job identifying volumes. But for some storm events, if you're trying to recreate them, if you have a small enough watershed or the meteorology generating the storm was kind of small scale, Prism may miss it. And so that's part of the reason we really like to mix and match some of the sources of data when we do. That's why the normalizer is so important, because you might get the volume, associated with Prism. That's going to do a pretty good job for that. And then using a finer scale, maybe a radar-based product might have some advantages. Now, any product does have blind spots, and one of the things to definitely keep in mind is what, for example, gauges. Those are typically not in highly mountainous terrain, and so there's going to be a lot of guesswork going on in the mountains. And at the same time, radar can have blockages. So definitely be skeptical of just about any product, and definitely verify what you're getting out of any of those estimates in highly varied terrain. That's definitely one of those areas. But in general, the question was asking, is Prism good for the United States? And so far, I would say for doing volumes or at least getting longer term totals, Prism is the best thing you can get probably for the continental United States. When it comes down to finer temporal and spatial scales, you might have to turn to other products to get that.
Yeah, for sure. We rely upon Prism quite heavily. It's a great data source, especially in sparse coverage areas. Like Greg was talking about, we use those for biasing quite a bit and use them within the normalizer tool. So definitely a good one. Good questions regarding AORC versus stage 4 versus MRMS. The everlasting battle between which data source is best.
Yeah.
There are definitely publications that go into data fidelity and accuracy comparisons to specific locations. I don't know of any that are like nationwide. I'm not sure if you're aware of those, Greg.
I haven't seen any continental scale ones yet, no. I've seen some applications of each of these, and it's there's no clear winner yet, and it's kind of unfortunate because I'd love to be able to just give a recommendation for which one to just start using. My personal, from ease of use and then from the results I've gotten, AORC has been extremely promising. Now, MRMS in a lot of places is also extremely easy to use, but AORC has a bigger advantage in that its period of record, like Tom mentioned, goes back to 1979. And so for certain studies, it's extremely valuable. AORC is also, it uses satellite estimation in addition to radar and gauge based. So it's definitely got some good things going on. It's getting easier and easier to access all these data sources. It used to be very hard. Now it's much more easy. And so I definitely think that if you've got time in a project, it's worth trying to evaluate what's going to give you the best estimates for the events that are important.
Yeah. And personally, I've used them all pretty heavily and relied upon them all heavily for various different uses. But all of them benefit from normalization at one point in time or another. So definitely check out that tool if you haven't already. Got some really good documentation. and tutorials and guides and videos related to them. So give the normalizer a shot. Let us know how it goes for you. Tommy, you want to answer the report generation question there?
Yeah, I can talk to that a little bit. So the report generation, that I think we've demoed that before in one of these, but I'm not sure. But anyhow, that was a major addition. I want to say it was 4.5. I could have that number wrong. It was in that kind of series 4.5 or 4.6 where we added what we called the standard reports. And that was based on calls from the field for years. Unfortunately, most of the requests for that feature were coming from kind of the consulting world, which we have a harder time partnering with just based on US laws and everything, and based on who we can take money from to do work. But then one of our partners did come in and ask that we could add that standard reporting option for the benefit of everybody. So you can thank them. But they asked for that standard report, and we did that, and it creates what it is. It's on Tools Reports menu, I believe, and it creates an HTML formatted report that's very neat and tidy. Some people may be familiar with, a long time ago, it was like a style sheet based report, and you had to create that style. You had to write your own style sheet against an XML file. It was very tedious. People had a lot of problems with it. And this new HTML report option is very easy. There's a few selections you can make to get kind of customize that report. And then it generates the HTML report, and you can print it any way you like. You can print it to PDF or print it to a physical printer. People in general are pretty happy with it. We have a few ideas of ways to improve it. If you have ideas on ways to improve that, feel free to send them in. Like the request was made in the chat, if we could add something like a plot of the basin model, and that's something that we've talked about recently in a scoping effort. So those kinds of things are great. I'd love to see it. If you have those ideas, just send them in. And then another thing I'll mention with that reports framework is we made it very extensible so that in the future we could potentially add more reports, not just the standard report. If you have your own report that you would like to add that you think might be beneficial to others, we can certainly consider that, adding that report in. So yeah, like I said, very extensible framework, and it doesn't have to just be the standard report. There can be several reporting options from that menu in the future if that's something that you or your, where you work is interested in.
All right, Jim H had a good question about storage outflow relationships. I think it can definitely get tedious to develop those, especially when you have to do some back and forth between steady state, HEC RAS, simulations, and HMS. There is an alternative to that. There are many alternatives to that within HMS. You can use different hydrologic routing methods. One that may be decent to get you off the ground and running is the normal depth approximation. So instead of defining those relationships external to HMS, you can assume a normal depth, and that'll actually develop the storage outflow relationships for you. That's ingrained. That's another routing method that's available there. Can't necessarily do backwater effects or any other things like that with that method, but that'll get you off the ground and running. Many other choices when it comes to routing. Everybody and their brother got a routing method. We got a bunch of those in there. Good questions about TR55, time of concentration. Now, David, you're also interested in that. Plans for that in the future?
Yeah, I think that was something that we are looking into, and partnering with the NRC hopefully to make that happen.
Yeah, the expression calculator that we added several versions back is really powerful for doing TC type calculations, TCNR. So I would take a look at that and see if that meets your needs. For specifically TR55, we have considered doing that, and we are hoping that the NRCS would be interested in funding that. So that could come in the next couple of years.
Yeah, and also a similar question for the multi-opening outlet structure with a whole bunch of different ways in which water can leave a project. That is another one that's been asked in the past. Definitely interested in adding on it. Just need to get a partner to do some of these things. So if you are interested, please reach out to us. If you're interested in any feature, right, reach out to us. Send us an email. We have the email list located there at the bottom. You can contact us to be added to the list. We'll let you know when new releases are made or major announcements are ready. You can also reach out to us there and send us any suggestions that you do have. Include a link to our documentation that's right there. We spend a significant amount of time with documentation. Without good documentation, what good is the software, right? We want people to be aware, A, of what new features are going into HMS and bug fixes, but we also want people to be aware of how to use them, right? How to use them effectively. So we spend a significant amount of time making documentation like the tutorials and guides. New and improved features are demonstrated within there all the time. Also spending a lot of time on training. Training is tis the season for training recently. So we got a lot of videos that are going up on our website and on YouTube that are available for people to learn from, watch, rewatch over and over and over again and learn from there. David, you want to go one slide? All right. So we just threw this at the end here. And notice that the font size is pretty small. This is a list of all the major features that were added within version 4.9. We had to go this small for the font size to actually make it fit. This was a huge amount of features that went into play here. We don't expect everybody to know exactly what all of these mean by just looking at 2 or 3 words. Every single one of these things is documented within A, our release notes, B, within the user's manual, and C, usually within the tutorial guide and the set of videos that goes along with it too. So if any of this stuff looks interesting, please check out the release notes. There should be links there for you guys to go and see any companion tutorials and guides or videos that goes along with it. We're all really, really proud of the features that were added within version 4.9. It was a monumental effort to get it all in there. And if you go one more slide in the future, David. Here's what we got in the works for version 4.10. Already 4.10 is shaping up to be a huge version as well. This stuff has got me really, really excited. I'm super, super pumped for some of the, again, quality of life enhancements, but also the really important new features. Just making everybody's lives easier, from building a model through running a simulation to viewing the results and making informed decisions for projects, and what to do when it comes to hydrologic modeling. We're all interested in that. It has been posted to our website. So if you want to go and grab Beta 1 from our website, it's ready to go there. That is essentially the portable package, so no admin rights are needed to download and use it. We have a link to our release notes as well that documents all these features. And we'll keep adding to it. We're going to shoot for a release relatively soon, sooner than we got out version 4.9 or the time in between version 4.8 and 4.9. We're shooting for a little bit of a faster turnaround on this one, but as you can see, 4.10 is already chock full of features. Very, very happy about that. If we didn't answer your questions, we'll definitely get back to you in an email. If we missed something, or if you think of something later, send us an email. We might ask you to post it on Discourse so everybody can benefit from the discussion, but we want to hear from everybody, especially how the software is working for you. Thank you for jumping on to the webinar today. Just a reminder, we did record this. We will post it to our website. We have a nice training page on our website there for everybody to see. Look at all the past presentations as well. This is the 5th in our series, and we're going to keep on going every quarter, putting these things out for everybody to see. Say thanks again for you guys jumping on. Hit us up on our email list if you want to be added to that and be aware of everything. But otherwise, have a good rest of your day and happy modeling, everybody. Thank you.